Okay, so we're gonna start. This problem is exercise 11.10. So I have all this formation in this diagram I made. So I put that the distance from the foot of the ladder to the wall is 3 meters. Then the ladder is 5 meters long. And also I put the weight of the ladder, which is 160 newtons. And also the weight of the man is 740 newtons. So right here I put also the normal forces of every single thing, and also the force of friction, which is right here, which is 0.40, the static friction, sorry. So I'm gonna start the problem by adding the weights to have the normal force of the whole thing. So that's gonna give us, it's gonna be 160 newtons plus 740, and that's gonna give us 900 newtons. So now we're gonna put it right here, so we can get the maximum frictional force that the question is asking. So that's gonna be 0.4 times the 900, and that's gonna give us 360 newtons right there. Okay, so that's the first part. This is the answer for the first part. So for part B, is asking what is the actual frictional force when the man has climbed 1 meter along the ladder. So first we gotta get all the R's, and I made a little picture to show it right here, a little drawing. So we have to get all the R's in order to get the angles. So R1 is the ladder, which is 5 meters long, and divided by 2 to get the middle point, where is so it's gonna be 2.5 meters, and then I'm gonna get the R2, where is the guy standing. So the problem says it's standing 1 meter, so on top of the ladder, so 5 minus 1 is gonna be 4, and the R3 is the whole length of the ladder, which is 5 meters long. Now we're gonna get the first angle, which is right here, so it's gonna be angle 1, and we're gonna use these two formulas right here: angle 1 sine, inverse sine of 3/5, and that's gonna give 0.6. And for the angle 2, it's gonna give us sine, inverse sine of 4/5, and that's 0.9. So now we're gonna use the sum of all torques, so we can find what is asking, that is the frictional force that is exerting when the frictional force when this guy climbed 1 meter above the ladder. So we're gonna put all the information we have in this big formula right here. So it's gonna be 2.5 times 160, that's the weight of the ladder, times the first angle, which is 0.6, plus the R2, which is 4 meters, times the weight of the guy, which is 740, times the first angle, which is 0.6, plus 5, the angle, the R3. So we have the frictional force right here, which we're gonna solve for that. So now the second angle minus the R3 times 900 times 0.6. And when we solve for that, we're gonna have 171 newtons right here. That's the answer for part B. So for part C, it's asking how far along the ladder can the man climb before the ladder starts to slip. So this is the formula we're going to use in order to get that, but we don't know the distance. We're looking for how long he can climb before the ladder slips. So first, we're going to use the same formula we used before, but now we're going to find the distance. So, sorry, the R2. So now we're going to put the 2.5, the R2 in order to find the distance. So 2.5 times 160 times 0.6 plus the R2 that we're going to plug in this formula right here after we know what's the value times 740 times 0.6 plus 5 times 360 times 0.9 minus 5 times 900 times 0.6 equals 0. So now, after we using the formula, it's going to give us R2 is going to give 2.30 meters. So now we're going to plug it in that formula right there. So 2.30 equals 5 minus D. So now the distance that the guy can climb is 2.7 meters before he slips. And that's it.